4. By the way, may I know who is the head of ME? Who's the head of ME? Yue Ying. And chairperson is? So chairperson. Oh, okay. Can maybe recess now or lunchtime go and change the duster, please? Oh, it's dirty.
I never realized the duster was
Okay, so 13.3 rates of change. I just want to go through one last question. Exercise 13.3, question 7. Okay, let's look at part I first. Okay, question gave these main points. It says that the petrol costs $2 per liter, van drives 24 kilometers per year. Annual cost for the petrol can be calculated based on this function, this formula, whereby the cost based on the number of kilometer per liter is equals to 4,800 over x. Okay? So part I wants us to find the annual petrol cost, which is C, if the car can travel at 3 kilometers per liter. Okay? Question did not actually tell us what is this kilometer per liter, okay, function. Depends on the car, it varies. Okay, so when looking at 3 kilometer per liter, that means that x, okay, is 3. So in order to find the annual petrol cost, which is C, yeah, 48,000. Can I copy wrongly? Oh, thank you. 48,000. Okay, so when x equals to 3, we get 16,000, and that will be the annual cost. Okay, so part I is fairly straightforward. We are just testing out the formula, see whether you know the context and then putting in the correct numbers into the formula or not. Okay. Then in part B, they gave a different rate for the number of kilometers per liter. So x is equals to 8. Okay, and the annual petrol cost is $6,000. purpose of highlighting this question is to bring our attention to part 2. Okay, part 2 says that we want you to find the average rate of change in Ben's annual petrol cost, okay, as X changes from 3 to 8. Alright, so what exactly does this question want? Okay, because they brought out the words average and then they also want us to find rate of change. Okay, so when it comes to average, I want us to draw the link, okay, to our understanding about average speed that we learned back in Sec 1. Okay, when we were in Sec 1, we learned that average speed will be total distance divided by total time, right? Okay, so a very typical thing that we encountered when we were in Sec 1 regarding such questions about finding average speed is that, for example, I walked from the staff room, okay, over to here, but maybe in between at the library I made a stop and rested for a while, okay, and then after that I walked up to here. Alright, the entire journey, the average speed that I have, the time itself will include even my rest time that I did at the library itself. Okay, that was what we learned when we were in Sec 1, okay, about how to calculate our average speed. Okay, so total distance, okay, simply is about the distance that I measure from the original start point, okay, to here itself. So if I really take a ruler and measure, okay, that will actually count my total distance. So I'm looking at the end point minus away the start point over the end time, okay, to the start time as well. So likewise, for this average rate of change that we want to find, okay, we're trying to find the average of the change in annual petrol cost, which is our CX, as X changes from 3 to 8. So what we're trying to find is to see how our CX actually change over, okay, our X change. Right? So that's what the question is actually trying to ask. Okay? So because the question phrased it in this manner, trying to find the change in the annual petrol cost over the exchange. Okay? Because average speed itself is having the idea of distance over time. Change in distance with respect to time. Okay, that's our understanding about speed. It's about change in distance with respect to time. That's why we have a formula being expressed this way, total distance over total time. Therefore, in this case, with that same phrasing, average rate of change will be the change in the annual cost over the exchange. Okay, so your CX change will actually be looking at 3 to 8, right? So that means the new one is 6,000 minus the old 16,000 over the change of 8 minus 3. Okay, and therefore, we see that the eventual value is negative 2,000 kilometer per liter. Okay, so what this means is that, okay, when you travel more distance per liter of the petrol, okay, the cost will naturally be smaller. The cost actually decreases because for 1 liter of petrol you take more distance. Okay, so therefore the cost will naturally be lesser because for that same distance now, okay, you don't need to spend as much money because for every 1 liter you can actually travel more. Okay, so which explains why the average rate of change in the annual cost will actually be decreasing, hence a negative value. Okay, so negative 2,000 is the answer based on our calculation. Yes, Josh. Sorry? Yes, you mean? Okay, and then part 3. wording, okay, but slightly different. Okay, part 3 says that you want to find the rate of change in Ben's annual petrol cost when x is equals to 5. So it doesn't have the word average at all. Okay, when it comes to average, we have the understanding about average speed, total distance over total time. That's why we see the change itself over another change. Whereas this phrasing itself, okay, what they want you to find is the instantaneous rate of change. Okay. Okay. The meaning of instantaneous means that at that particular point, okay, what is the rate of change? Okay. So for example, if I have a curve like that, okay, and if this curve were to be representing your cost over the distance traveled, distance per kilometer, per liter, sorry. Okay. What we're trying to find is that at this particular point, okay, how is that tangent, okay, that we draw, how is that gradient value going to be? Okay, that is what this question is trying to find. Unlike this one, okay, so this is when x is equals to 5. This one is trying to find out, okay, when x is equals to 3 and when x equals to 8, I want to see the gradient from this point to this point. Okay, so part 2 was trying to find out the gradient of this overall change, the average itself. Whereas in part 3, you're trying to find at that particular point, okay, what is the gradient going to be? Okay, so if you're trying to find at that particular point, the instantaneous one, what we need to do is to actually do a differentiation of the function. So, given that Cx equals to 48,000 over x, differentiating it, we will get negative 48,000 x power negative 2. Okay, and at that particular point when x is equals to 5, we replace x with 5, and we will get the value negative 19200. Sorry, I missed out a dollar sign over here. Oh, sorry, extra 0. So our value for the rate of change will actually be negative 1920 kilometer per liter. Okay. Alright. Questions? Okay, so there is a difference in the phrasing over here. One says average, the other one doesn't average. Okay, when it comes to average, we really look at what is it that we're looking at, the quantities we're looking at. So we have your annual petrol cost, okay, versus your x. So that's why we're looking at this. Whereas in part 3, we're looking at a particular point, okay, what is the rate of change? So therefore, we need to look at the differentiation and then put in the value. Okay, so that we can determine the gradient of the tangent of that particular point, and that will be 1920. Okay. Okay. I can't actually go deeper into this one. Okay. I think that I can sense that you're a bit lost in this. I think it will make more sense. Okay, once we go into kinematics. Okay. When we go deeper into more examples, especially related to speed. Okay? And it does rely a little bit on your physics concepts as well. Okay? So when we go towards the end of the chapter and you don't have physics concept, I think that will be a new challenge for all of us. Okay? Okay, looking at the time now, I think I shall not start on connected rates of change. Okay, for 13.3, I'm not going to give any homework. Okay, because I think that it will be more glaring. Okay, when it comes to 13.4. Okay, so I'll just give 13.4 homework. 13.3, I won't give homework. Alright, so that will be good news, I hope. Then we'll end here for today. Tomorrow I'll finish up 13.4. Okay, then Wednesday I will want to actually go into Emacs.